All right, Honors Algebra 2 and Algebra 2. This is page 6 in your Chapter 3, Part 1, Game Plan. What I'm going to do is I'm going to do a few of these. These are solving systems of linear inequalities, okay? Two graphs here, they're both inequalities. So something like number 2, what we have here is, let me handle that one. Y less than 1/2 x minus 4. So I got a negative 4. It's the y-intercept. And then I am going to go up 1 over 2 a few times. Up 1 over 2. What I have here is a dotted line. Less than means I shade below. Okay, then I have my second graph here. Y greater than negative 2x. Okay, so when I go to graph greater than negative 2x, there's a y-intercept of 0. Slope is down 2 over 1, down 2 over 1. A solid line greater than means I'm going to shade above. All right, where the shading overlaps, is my final answer. Okay, that region of feasible solutions where the shading overlaps. All right, so that's number 2 there. How about we talk about one like number 4 on this page? One like number 4. All right, I know on your page you can see that's 8x minus 2y greater than 16. I'm going to graph that one here in blue. So I'm going to say 8x is equal to 16, cover-up method, x is 2. Negative 2y is equal to 16, y is a negative 8, cover-up method. Okay, so the y-intercept, negative 8s, x-intercept of 2, says greater than, so dotted line, and I'm going to shade. Actually, be careful here. I'm not going to shade above. It's my fault. Notice it says greater than, but you have a negative y. I'm going to plug 0, 0 in here. 0 in for x, 0 in for y. I get 0's greater than 16, which is false. If I get a false statement, that means 0, 0, which is here, is false. I'm going to shade it below. All right, be careful there. Next one. 5x is equal to 15, cover-up method. X is equal to 3. 3y is equal to 15, cover-up method. X is 5. So x is 3, y is 5. Less than. Again, I'm going to plug 0, 0 in for x and y. 0 is less than 15 is true. 0, 0 is true, so I'm shading everything in that region. And overall in black, I'm shading all of this. Where it overlaps, red and blue. Where red and blue overlaps, that's where I'm shading. All right, let's do a few more of these graphs. Oh, this next page here, number 2. On this next page here, number 2. Okay, at the top it says x or y is greater than or equal to negative x plus 3, so the y-intercept's 3. Graph this one in blue. Slope is negative 1, down 1 over 1 a bunch, a solid line. And I'm going to shade above. Next one, y less than 2x minus 7. Negative 7 is the y-intercept, slopes 2, up 2 over 1, up 2 over 1, up 2 over 1. Dot, 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 dot. Gonna shade below. If y is all by itself, you can trust it. Again, where the shading overlaps, so that is where you're going to really shade in. That's your region of feasible solutions. All those points make those two statements true. All right. And then how about one here like number 4 on this page? And then we'll mostly see everything. So it says 6x minus 2y greater than or equal to 12. We can do that one in red. 6x is equal to 12. X is 2. Negative 2y is equal to 12. Y is a negative 6. X-intercept 2, y-intercept's a -6. Greater than or equal to means solid line. Make yours not windy like I did mine there. I'm going to test 0, 0. So 0 greater than or equal to 12 is false. 0, 0, which is above the line, is false. So I'm going to shade everything below. All right. Then this next one, 3x plus 4y is greater than 12. Cover up method. 3x is 12. X is 4. That's the y-intercept. 4y is 12. I'm sorry, that's the x-intercept. The y-intercept is 3. Dotted line, it says greater than. Again, I'm going to test 0, 0. Plug 0 in for x, 0 in for y. I get 0 is greater than 12, which is false. So 0, 0, which is below the line, is false. That means I shade everything above the line. Where red and blue intersect is my region of feasible solutions. Okay, that is the name of the game for all of these. This was page 6. I know we got like A in there. On this next page, how about 6 and 8? All right, 6 and 8 on this next page. X is less than 3. That is a dotted vertical line. I'm going to shade to the left, everything to the left of this. X is less than 3. Y less or greater than or equal to -4. There's -4, solid horizontal line. I'm going to shade above. Everything above that line represents a y value greater than or equal to -4. There we go. Where red intersects with blue. It's my region of feasible solutions. And then honestly, I feel pretty good about that. Let's go here. Especially if you're in honors algebra 2 at the moment. Let's talk about a few of these real quick. Solving a system of 3 equations. Oh boy. Yes, I really mean it. So what guys, we have a triple here. System of 3 equations. I'm going to write my answer as an order of triples, what I meant to say. So I want to say bye-bye to a certain variable. In all of these equations, look at the y's. They're very, very similar. I got a -3y, +3y, -3y. So I'm going to say bye-bye to y. See, if I put equation 1 and 2 together, I can get rid of those y's pretty easy. I can add both equations together to get 3x plus 2z is equal to 11. That's my new equation, equation 4. My whole goal is to get something that looks like pages 9 through 11 there, I think. Definitely page 11 where I just have a 2 by 2. All right, a 2 by 2, and then I can solve that. So what I'm going to do next is I added 1 and 2 together. I have to put 3 together with something. I want to get rid of the y, so I'm going to put equation 2 and 3 together next. Equation 2 is 2x plus 3y minus z is 15. Equation 3 is 4x minus 3y minus z is 19. Again, I want to add them together because I have opposite sign for the y's. 6x minus 2z is 34. Those two equations now, 4 and 5, I'm going to put together. Okay, now I have 2 equations with just x and z in them, and I can use elimination now to find x and z. I'm going to put equation 5 underneath here. 6x minus 2z is equal to 34. This is perfect because the z's are opposite. So what I'm going to do here is I'm going to add the equations together. I get 9x is equal to 45, and boom, the domino effect starts. I get x is 5. With that x is 5, I'm going to use equation 4, which said 3x plus 2z is 11. 15 plus 2z is 11. 2z is a -4. Z is a -2. I'm going to go back to equation 1 here, or I'm sorry, equation 2. You go back to one of those original equations. That would be equation 2. And it's going to say 2 times x plus 3y minus z is equal to 15. Okay, 10 plus 3y plus 2 is equal to 15. 3y plus 12 is equal to 15. 3y is 3. And y is 1. I write my answer as an ordered triple, x, y, z. 5, 1, negative 2. And that is the name of the game. This is the hardest one in the game plan for sure. These types. So that's equation, that's number 1 there. We'll do a really easy one, then I'll try one more with you, and that'll be good. You might try the others then on your own. So hopefully an easy one. I already know what z is, so I'm going to plug it in there. Y plus 2z is equal to 0. Y plus 4 is equal to 0. Y is a negative 4. Then that first equation, x plus 2y plus 3z is 6. X minus 8 plus 6 is 6. Uh-oh. X minus 2 is 6. X equals 8. Eight, negative 4, 2. All right, then let's take a look at this page, one of the second to last page here. This one here that says number 7. Again, when you have one on your own, it's all about looking what variable would be very, very easy to eliminate. And look at the z's. They match up really well. So by z. Again, this is equation 1. This is equation 2. That's equation 3. What I'm going to do first, and you can do this as a shortcut, especially if you're in Honors Algebra 2, is I'm going to add equation 1 and equation 2 together. And I'm just going to write that I'm adding equation 1 and 2 together. Okay, because I can add them right here. 5x, 2x, that's 7x. 4y plus a negative 2y y is 2y. The z's cancel. 1 plus 1 is 2. That's equation 4. Okay, so especially if you're in Honors Algebra 2, I'd expect you to do this type of work. And then I need to add equation 3. I'm going to put 3 with 1 because z's are opposites. So I'm going to do equation 1 and 3 together. 5x plus a negative 1x is 4x. 4y plus a negative 1y is 3y. The z's cancel. 1 plus 2 is 3. That is equation 5. And I'm going to put equation 5 right under equation 4. And I'm going to see what I've got. So unlike the first one I did, nothing matches up exactly as either the same sign or opposites. I'm probably going to get rid of the y's. I'm going to take that first equation and triple it. That second equation and double it. In that first equation, I got 21x plus 6y is 6. And then I got 8x plus 6y is 6. The y's are the same sign, so I need to subtract them. How do I get 6 and 6 to be 0? I subtract them. I get 13x is equal to 0. X is 0. Then I pick one of the equations. I don't know, equation 5 here. It's looking at me. 4 times x plus 3y is 3. That means 3y is 3. That means y is 1. X is 0. Y is 1. I'm going to come over here and I'm going to use, I guess I'm going to use equation 3. The opposite of x minus y plus c is 2. Negative 1 plus c is 2. Z is 3. 0, 1, 3. All right, that is my second one there. A few of them get a little interesting in there, but other than that, if we can handle 7, we're in good shape. All right, then you got to make sure on this last page here, let's just go over, number 1, solving a system by graphing. Again, let's make sure we know how to do something like 1. This first one here, negative 2 is the y-intercept. down 3 over 1, down 3 over 1, down 3 over 1. I can also go up 3, 1 to the left, up 3, 1 to the left, up 3, 1 to the left. This is a solid line. Oh, goodness. Make sure yours hits the dots, unlike mine. And in blue, y-intercept of 3. Down 1, 2 to the right, down 1, 2 to the right. That's not going to work, so I go up 1, 2 to the left, and ding, 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 they intersect. There, negative 2, 4 is their intersection. All right, folks, I think that is good enough for right now. There's other videos available. This is Yak Math Videos signing out.